Thank you guys for inviting me and my coworker Nicole here today. My name is Harrison. I'm the Asia Pacific Developer Advocate. What that means is I just do developer-facing events, activations in the Asia Pacific region, in person. It could be a workshop, it could be 3-day to 1 week or even 2-week long boot camp style, ending it with a hackathon, as well as we do online 2-month long hackathons as well. Is there a clicker or next be? So I know the slide number is scary, but what I do is I separate slides out so that you don't need animation, because sometimes you export it as PDF. So you just need to hit the next, and it looks like animation is built into the PDF. So don't be scared, we're not gonna be here until tomorrow morning. We'll try to finish this in 30 minutes. Yeah, next slide. So when I was younger, when I had more hair, people started coming to me saying, "Hey, you look like the guy from The Walking Dead." At that time, I didn't watch The Walking Dead TV series, but there's a character called Glenn, and yeah. But then I started getting older, started losing some hair. I stopped getting that comment. Next slide. In 2019, the same actor had a Netflix TV series called Beef. So they're like, "Hey, you look like the angry guy from the Beef Netflix TV series." Next slide. So this is my latest movie, if you guys want to watch. It's also on Netflix. Next slide. So Elon Musk. And next slide. And this is the founder of Telegram. Not his name, but both of these gentlemen reverse aged. So hopefully one day I'm able to do this too. Right. Next slide. Okay. So what's wrong with the web today? Next slide. These are just some examples of what is wrong with the web. 30% of commission purchases go towards centralized platforms like Google App Store or Apple App Store. Next. The creators of the economy, right? Whether it's YouTube or it could be, again, mobile apps, they put in a lot of hard work, but then the platforms take a lot of the money in between. So that's also a problem in the current Web 2 world today, is these siloed giant enterprises that own a lot of the services that we use today. Next. So the essence of Web3 is solving this issue of this relationship. So how do we basically give the more power back to the creators and the users? And Web3 is the technology that's well suited for defining, digitally defining ownership and assets. So for example, like digitally proving that I own this object and I want to just give it to someone else. You can do that on the blockchain basically. Whereas in the current internet that we're used to, we're trusting Google or we're trusting Amazon or we're trusting Instagram to say, "Oh, this is, you just have to take my word for it." Is basically the internet that we are used to today. Next slide. So Web3 is about coordinating the relationship between these buyer, creator, and instead of the platform, now it's the smart contracts, algorithms that are going to be doing the work. So you might have heard the term trustless environment. So you're no longer trusting humans, you're just trusting the code. Next. Okay, so then I want to talk about upgrading the internet with Sui. And this is just my rendition of a beginner intro friendly to Sui. Next. All right, so let's talk about the evolution of the internet. So in the 90s, you must have heard, if you were born early enough, you must have heard this sound.
Dial-up.
So it brings back good memories, I hope. Each household had one phone line, and if you want to access the internet, you have to connect that phone line to a modem, and then go through that scary process of connecting to the internet. Once you're connected to the internet, your home cannot receive any calls, you cannot make any calls until you log out of the internet, disconnect. Next slide. So in this world, you're stuck with the average internet speed of 56 kilobits per second. It's the earliest form of the internet that we know, and it's limited to very simple websites, like text-based websites. But this laid the foundation of the internet that we know today. Next slide. So, to load a 10-second video during this time, during this 1990s era of dial-up modem internet speed, how long do you think it would take? We have 1 hour. Okay, any other guesses? A 10-second TikTok video, Instagram video, how long would that take? 30 minutes? All right, let's reveal the answer. 6 minutes, 6 seconds. You might not think that's long, but it's actually eternity for the internet that we're used to today. Next slide. But during this time, before, so this is the next era when we have MSN, but let's go visit what did we use before MSN. Next slide. Yep, next slide. This, who recognizes this? One. Okay, we can be friends. Okay, this is called ICQ. This is possibly the first consumer-facing messaging app. Everything that we're used to today with messaging comes from ICQ, is how I would believe it. For those of you who know any Chinese apps, the first one was called QQ, and basically they based off of ICQ. And QQ turned into what we know today as WeChat. Now, ICQ, when they started, the UI sucks, right? And it's just very engineer-focused, like, you know, you have all the menu lined out, like every single button is there. Next slide. So, you are given a username by default. You don't get to set your username. You're given a long string of numbers, and that's your username. And back then, we're able to memorize this because we didn't have a smartphone in our pocket. But this is kind of similar to the blockchain user experience we have today. So if you've ever created a wallet before, you get a long string of numbers and text, and that's your wallet address. So in this era, user experience is not great. But that's the first layer, or the very first growth phase that the internet we're used to today had gone through. Next. And next. So in this era, we had ICQ, simple emails, chess, simple games like chess, and websites were very read-only focused, which meant you cannot submit any information of your own, you cannot upload images, you cannot write your status for today. You just got to access websites that were created by governments, universities, or big companies. Next slide. Next, we have broadband speed. Next slide. It's 1.5 megabits per second in the 2000s. We have YouTube with buffering, which means you have to pause the YouTube video, let it load, and then play it again. And that's what we had to deal with. Facebook, back then it was just text. Instagram only had photos. Messenger was the next messaging app, an upgraded version of ICQ, and this is where people were able to start customizing their usernames. So the user experience improved in this era. Next. So how long would a 10-second short-form video take to load this time? Earlier was 6 minutes. How many minutes now? 3 seconds. All right, next slide, or it's 13 seconds. So you're off by 10 seconds. That's pretty close. 13 seconds today might not seem long, but it is very long for us in the room. Right? If it's not loading in, let's say, 8 seconds, you might just swipe to the next doom scrolling video. Next. And next. So fiber optic cable, so infrastructure improved, right? So once the infrastructure of internet improved, we have 42 megabits per second, and this is basically the internet that we have today. Next. So now we're able to enjoy YouTube without buffering. We get to enjoy Instagram with videos, Netflix, just endless video streaming, data intensive. Okay, next. So I run those today. To load a video would take approximately a second or less. Next. And next. And next. All right, so Web 3 for the most part is operating at the speed of Web 2 or the internet that we're used to, but from the 90s. And next slide. The goal is, I think the SWE's main goal is to really upgrade the Web 3 infrastructure so that we bring that Web 3 experience speed that matches what we're used to today in the regular internet world. Okay, so we try to achieve that by, next slide. Our goal is to make the internet speed faster, but safer at the same time, because we've seen a lot of hacks on different chains, different blockchain. I'm sure you've heard of millions and hundreds of millions of dollars being hacked. So next. And we try to make it safer and make it faster with a blockchain called SWE and with a coding language called Move. Next slide. And next slide. So I'm going to give you 3 analogies to help you understand why SWE architecture makes it fast compared to other blockchains. So we're going to take the example of the immigration line at the airport. It could be at the train station, or let's say a museum, anything that requires lining up. Next. So imagine these are the lines, but next slide. You have one immigration officer, or just one line where you can line up. Obviously, the line will get very long, very crowded. Next. So how do we get more people through? Obviously, you have more booths, or more ticketing booths, or more immigration officers. Next. Next. So we can now divide the line by 3. Sorry, there's some Mac OS versus Windows thing going on here, but it's just 3 lines. Next. And what other you see at airports or immigration lines? We see lines for locals, foreigners, people with kids under 18, or flight crew, or diplomats, or APEC business cards. All different